So now we're going to talk about some cool things about working with radicals. So before we really get started, stop the video and try the problems A through F. So hopefully, once you got all the answers in here, you should have gotten that the first one is just 5, the second one's 11, 7, 30, 27, 91, right? Because if you think about it, if I'm doing the square root of 5 times the square root of 5, you just multiply 5 times 5, which is 25. That would give you the square root of 25, but the square root of 25 is 5, right? The square root of 11 times the square root of 11 would give us the square root of 121. Well, the square root of 121 is just 11. The square root of 7 times the square root of 7 would give us the square root of 49. Well, the square root of 49 is just 7. So then, even after doing just the first three, you then are really like, well, the square root of 30 times the square root of 30 doesn't even matter that that's the square root of 900 because we know we're going to end up with the radicand, right? I don't even know what 27 times 27 is, but it doesn't matter because when you square that, you just get 27. Same with 91 times 91, right? So the conclusion I'm hoping that you came up with here is that when multiplying identical radicals, multiplying identical radicals, the result is the radicand, right? Remember, the radicand is the expression inside the radical symbol, right? So you also could say when squaring a square root, the result is the radicand, or the result is the number inside the radical. There's many ways to say it, but basically that's helpful because it saves us from having to know what 27 times 27 is when we're multiplying radicals. So that's going to help us when we are multiplying radicals. Let's take a look at the next set of problems. So if you take a look at G, when I'm doing the square root of 13 times 2 square root of 13, well, we just learned that if I'm multiplying the square root of 13 times the square root of 13, that's just going to give me plain old 13. And then now we're multiplying that by 2, so that's just 26, right? So the next one, 5 times 4 would be 20, and the square root of 6 times the square root of 6 is just 6, right? Oops, I forgot 20, times 6, which is going to give us 120. And so then negative 4 times 2 is negative 8. And then the square root of 12 times the square root of 12 is just going to give us 12. And negative 8 times 12 is negative 96. Now, the reason that I want you to really understand this, or one of the reasons I want you to really understand this, is going to help us whenever you're multiplying radicals together. So notice J and K, I purposely made those two problems exactly the same. Because if you're doing J, let's just look at J. You would multiply, if I'm doing the square root of 15 times the square root of 3, many of you would just say, well, neither one of those radicals can be simplified, so let's just multiply them together. That's going to give me the square root of 45, right? So now I'm thinking about the square root of 45, and I'm like, well, that's not in simplest form because 9 goes into 45, and that's a perfect square. So then I would have to break up 45 into 9 times 5, right? And then the square root of 9 is 3, so I would get 3 square root of 5. So that's easy enough. We just multiply, pull out the perfect square. However, we can do it a different way, right? Let's say I didn't feel like doing 15 times 3. I could think to myself, well, does 15 and 3 have a factor in common? And the answer to that is yes, right? 3. So think about breaking up 15. I could break up 15 into the square root of 5 times the square root of 3, right? Because 5 times 3 is 15. And then we're multiplying that by the square root of 3. And then what we just learned is when I multiply the square root of 3 times the square root of 3, that's just 3, right? So then I get 3 square root of 5 that way. Now, it doesn't matter which way you do it, except it's really helpful when I'm going to problems like L, right? 77 times 35. Now, we don't know what 77 times 35 is off the top of our head. If I plugged it into my calculator, I would get 2,695. Now, I personally don't want to try to find a perfect square that goes into 2,695. I want to think of a better way to do the problem, an easier way. So before I multiply 77 and 35 together, I'm going to think, well, is there a number that 77 and 35 have in common, a factor? And the answer is yes, it's 7, right? So I could instead break up the square root of 77 into the square root of 7 times the square root of 11, right? Because 7 times 11 is 77. I could break up 35 into the square root of 7 times the square root of 5, because 7 times 5 is 35. So I've just broken everything up. Oh, well, I have two of the same radical. The square root of 7 times the square root of 7, well, that's just going to give me 7, right? Because it would give me the square root of 49, which is a 7. And then you can multiply together the square root of 11 times 5, which is going to give me 55. Now, that doesn't necessarily mean you're finished, right? It just helped us get started. We would then need to start thinking of our factors of 55. Well, we have 5 and 11. And then 11 and 5 are both prime numbers, so there's not another perfect square that goes into either 11 or 5 or 55. So we do know we're done. So we do always want to just double check, make sure that we've got the biggest perfect square out of the radicand. So let's take a look at the next one. Go ahead, actually, if you think you've got it, go ahead and stop the video, give it a try, and then tune back in and see if you got it right. I will go ahead and explain it, though. So then I've got 30 and 42, so I need to start thinking of factors of 30 and 42. Think of some factors that they might possibly have in common. So 30 has 3. 42 also has 3, but there's a bigger one, right? 6. We could break them into, we break 30 into the square root of 6 times the square root of 5. We break 42 into the square root of 6 times the square root of 7, right? And so the square root of 6 times the square root of 6 is just 6. And then you could put your two radicals together. 5 times 7 is 35. So you get 6 square root of 35. And again, I would encourage you, double check, make sure your answer is right, or that your decimals would match by plugging it into Desmos and just see, does the square root of 30 times the square root of 42 equal to 6 square root of 35? And then, of course, we're done because, again, there's not a perfect square that goes into 35. So now I would definitely say, go ahead and stop the video, try n, and then definitely come back to me and make sure that you've got it right. So stop the video, give it a try. All right, if I'm predicting correctly, many of you probably immediately noticed that 4 goes into 120 and 84. You may have noticed a bigger number. If you did, awesome. But most people are going to start this with 4 times 30 and 4 times 21. So then I'm noticing I've the square root of 4 times the square root of 4 is just 4, right? Well, when I multiply 30 times 21, that's still a pretty big factor. I get 630, right? So we're not finished with this problem because there's definitely a perfect square that goes into 630. So let's just think about the number 63, right? 9 goes into 630, right? Because 9 goes into 63. So I have to take it now a step further, right? I have to do 4 square root of 9 times 70, and then because the square root of 9 is a perfect square, I would pull out the square root of 9 is 3, multiply that by the 4 to get 12, and you would get 12 square root of 70. Now that's not the only way you could have gotten there, right? You may have noticed a bigger number that goes into 120 and 84. You may have noticed 12, right? But most of the time and I shouldn't say most of the time, we don't always notice the biggest one. So I wanted to give you an example of a time when you would have to go just further, right? You could have started off with the square root of 12 times 10, and then the square root of 12 times 7, and you would have immediately ended up with 12 square root of 70. All right, again, stop the video, give the next one a try, and tune back in. All right, this one, again, you would definitely have to take this one down again, right? The number that goes into 55 and 40 is 5, right? So I started off with 5 times 11 and 5 times 8. You could right here be like, wait a second, there's a perfect square that goes into 8, it's 4. You could go ahead and simplify this into 2 square root of 2 right now if you wanted to, but I'm predicting that many of you probably didn't notice that right away. So you just multiply the square root of 5 times square root of 5 and you get 5 square root of 88. Now if you stopped there, you're just not done, right? Because there is a perfect square that goes into 88. 88 is divisible by 4. 4 times 22, right? So then I pull out here the square root of 4, multiply it by the 5 to get the 10. So you end up with 10 square root of 22. All right, the next one, I'm going to go ahead and just take this one with you. There's a couple of ways to look at this one. You could go ahead and start pulling out perfect squares right away if you want, or you could just start multiplying it all together. I'm noticing the variables, and I kind of want to just put the variables together right away. That's what my brain says to do. Again, the way that I'm showing you to do it is really, there's suggestions on how to get the right answer. There's multiple ways to get the right answer. If I do the square root of n to the 4th times the square root of n to the 7th, remember you just add the exponents. It's going to give me the square root of n to the 11th. So I'm just going to put that off to the side here, square root of n to the 11th. Now I'm going to multiply the square root of 12 times the square root of 18. And before I multiply 12 and 18, let's think, what are factors of 12 that share factors of 18? You may have said 3, but you may have said 2, but then if you think about it, 3 times 2 is 6, right? So the biggest one is 6. So what I would do is I would break up the 12 into the square root of 6 times the square root of 2, and I would break up the square root of 18 into the square root of 6 times the square root of 3, right? So then if you think about it, the square root of 6 times the square root of 6 is just 6, right? And then 2 times 3 is the square root of 6 as well. So I'm going to leave some space because I need to pull out some variables here. So that's going to be 6 on the inside. Now, the square root of n to the 11th, well, that's the same as saying the square root of n to the 10th times n, right? Because it's odd. So you're going to leave an n on the inside. And then you're going to pull out and get an n to the 5th on the outside. So it's really just a method that I would use before I multiply. You, of course, could fully simplify 12n to the 4th. You could fully simplify 18n to the 7th and then multiply them together. That's another option. All right, go ahead and try the next one. Give it a try. Stop the video. All right, now this one, automatically I just noticed that I've got the square root of 23 times the square root of 23, which I know is just going to be 23. And then I multiplied that by the 2 on the outside. And then I'm left with this a to the 9th. That's odd, so I broke it up into a to the 8th times a. I pulled out the square root of a to the 8th, and I got a to the 4th. So it's 26a to the 4th, square root of a. So that's all I've got for you today on this. So if you are at all struggling, of course, please find somebody to help you. Ask me, ask a neighbor, get some help, ask your parents, do what you need to do to make sure that you fully understand this. All right, good luck.